Okay, good morning. So I provided you practice problems in preparation for our quiz 1. So today I'll be computing. Okay? So I'll be solving the given practice problems for your reference. Okay, so we'll start with the first question. Okay, so the first 6 questions are multiple choice type of questions, and the topic that we will be dealing with are antiderivatives. So that means we're using the power rule, and then we have the integrals leading to logarithmic as well as for exponential functions. Based on the problem set, the specific method is not provided, so therefore we should be very observant, okay, so on the type of integrand that is given, and then based from there, so we try to identify so which is the most applicable method to use. Okay, so for example in this one, so find the antiderivative of 2x plus 5 and then x squared plus 5x raised to 7. As I've mentioned during our discussion, okay, so whenever a given polynomial is raised to a certain power, it is most likely that we will be using power rule. So similar to this one, so we have an x squared plus 5x and then it is raised to 7, and then we are given a binomial 2x plus 5, so which is multiplied to dx. So this is most likely using a power rule. Okay, so in that case, so recall that we are using the formula for the power rule as if it is u raised to n du, so that would be equal to u raised to n plus 1 all over n plus 1 plus c. And thus, in this case, so I can rearrange the given integrand into this format. So in such a way that it would become u raised to n, multiply it with du. So I am assuming that the x squared, so plus 5x raised to 7 will become my u raised to n. So the derivative of that, so I am assuming that I'll be able to get the 2x plus 5 and then multiply it with dx. Then from there, so we can already assume, so for the value of u, so in this case, that is x squared plus 5x. So that is our u. And then we derive this one, so that makes it derivative of x squared is 2x plus 5. And of course, so we multiplied it with dx. And as we can see here, so our du is exactly the same as the binomial multiplied with dx. So substituting the x squared plus 5x raised to 7, that's the same as u raised to 7, and then the 2x plus 5 dx, that is the same as du. And thus we can use our power formula. So that is u raised to 7, that would be u raised to 7 plus 1 is 8 all over 8 plus c. But then we have to transform it back to the original variable of x. So that makes it 1 over 8. Okay, so 1 over 8, and then our u is x squared plus 5x raised to 8 plus c. And thus, so the first option is the correct answer. So 1 over 8, so times x squared plus 5x raised to 8 plus c. So that is our final answer. Okay, so you may always pause it. Okay, so if you have or if you need to clarify something, but I'll proceed right away. Okay, so let's say we are given this one. So evaluate the following integral. So we have the integral of the square root of x plus 1 over the square root of x dx. So in such cases like this, so whenever there is a radical symbol, okay, or radicals that are given on the integrand, okay, so the easiest way on how to approach this one is to transform the radical symbol into a rational exponent. So in this case, so this will be square root of x, that's the same as x raised to 1/2, and then plus 1 over x raised to 1 half, and then multiply it with dx. And then if the power at the denominator is other than 1, okay, so if we have a certain variable whose power at the denominator, it's not 1. Okay? Because if it is 1, so most probably that would be logarithm. But anything or any exponent other than 1, so what we do, as long as it is a monomial at the denominator, we move it at the numerator. Okay, so in this case, so this one would become x raised to 1 half. And then, so what changes again is the exponent of the, or the sign of the exponent. Okay, so not the sign of the base. So this one would become x raised to negative 1 half, multiply it with dx. And then, so since this is already in the standard form, so we can now integrate this one, so using the power rule. So again, so our n is 1 half. You may always use your calculator, but then, so 1 half plus 1, so just like what I mentioned, we just add the numerator and the denominator. So 1 plus 2 is 3 all over 2. So 3 all over 2, and then all over 3 all over 2. And then plus, this one is x raised to negative 1 half plus 1 is negative 1 plus 2 would be positive 1. So that makes it x raised to 1 half all over 1 half. And of course, we have the plus c there. So this one will become, so we have a fraction at the denominator. So if we move it up, so it will just be the reciprocal. So that is 2/3. Okay, so 2/3 of x raised to 3 over 2, then plus 2, x raised to 1 half, and then plus c. But then, so looking at the given problem, it's not exactly the same as those in the choices, but then we can transform this one, so transform it back to in the radical form. So in this case, so that would become 2/3. So x raised to 3 over 2, that is the square root of x cubed. Square root of x cubed. And then plus 2, the square root of x plus c. But then, x cubed is the same as x squared times x. Plus 2 the square root of x plus c. So finally, x squared is a perfect square, so I can move it out. So that would become 2/3, and then times x, multiply it with the square root of x, plus 2 the square root of x, plus c. So that makes the first option to be the answer. So 2/3 x the square root of x, plus 2 the square root of x, plus c. Okay, so for the third question, so we have x cubed dx all over 1 plus x to the 4th raised to 1/3. Okay, so in cases like this, so there is a binomial at the denominator and then it is raised to 1/3. So things like this, so we transform it again on this format, the u raised to n du. The binomial 1 plus x to the 4th should be transferred at the numerator, and then the rest so will become the derivative. So for this particular example, so this would become, so I'll move up, so the 1 plus x to the 4th, and then raised to the 1/3, so will become negative 1/3. And then we multiply it with the x cubed dx. So from here, so it resembles the power rule. So we set for u, so to be 1 plus x to the 4th, and then the derivative of u, so will become, derivative of 1 is 0, derivative of x to the 4th is 4x cubed dx. But then, this is 4x cubed dx, so this is x cubed dx. So we have something in excess, okay? Or this would be the same as du all over 4 is equals to x cubed dx. And then we change everything. So 1 plus x is u, so raised to negative 1/3. Then x cubed dx is the same as du all over 4. So in dealing with this, so we can move out 4, so it will become 1/4 the integral of u raised to negative 1/3 du. Then we use the power rule. So u raised to negative 1/3 plus 1, that would become negative 1 plus 3, that would be positive 2, so 2/3 all over 2/3 plus c. And then this will be, so 1/4, so the reciprocal of 2/3, so that would be 3 all over 2. Then we multiply it with our u, so which is 1 plus x to the 4th, then raise it with 2/3. So we have then, so 3 all over 8, so 1 plus x to the 4th raised to 2/3. So again, so based on the choices, so we don't need to transform it back to the, or to change the rational exponent into a radical. And of course, I forgot, so we should have a plus c at the end. So plus c. Okay, so for example number 4. For example number 4, so we have x squared minus 5x multiplied with 3x plus 6 all over x squared minus 3x minus 10. So it involves polynomials and then product of polynomials. So you may always do the operation involved, but then if factoring works, okay, so try to do factorization first if it is possible. So for this particular example, so we simplify this first, so before even solving, okay, or finding the solution, or finding the integral right away. So to do that, so let's start with x squared minus 5x, so something is common, so which is x. So I can factor out x. So x squared divides x is x, then 5x divides x is minus 5. So that is for the first term. The second term, we have 3x plus 6. So something is common is 3. So 3 then is multiplied with x, then 6 divides 3 would be 2. So 3x plus 2. Then the denominator, so we have x squared minus 3x minus 10. So is this factorable? So what's the factor of 10? So that will give us a 3. So factor of 10 is 10 and 1. If we add both, that would be 11. If we subtract, that is 9. So we cannot use 10 and 1. So we proceed with the next. The next factor is 5 and 2. Okay, so if we add 5 and 2, that's 7. If we subtract 5 minus 2, that is 3. Okay, so we could have 5 and 2. So we have x and x, a 5 and a 2. So we need to get a negative 3x. So since we're subtracting, so 5 should be negative, and then 2 should be positive. Okay, so that makes it negative 5x plus 2x, negative 3x. And negative 5 times positive 2, that is negative 10. Okay, so that makes it factorable. And as you can see here, so we have x minus 5 and x minus 5 are common to both numerator and denominator. X plus 5 and x plus 2 is common as well. So we were able to do this one since that's just a product. Okay, so we cannot do that if the sign here is plus or minus. Okay, so it's just product, so therefore, so we can do the cancellation there. So So just leaving us to a very simple integrand. So 3 times x, so that would just be 3x dx. And thus we'll have 3, so x squared all over 2 and plus c. So giving us the first option again to be the answer. Okay, for number 5. So find the integral of the square root of x to the fourth plus 2x squared dx. Square root of the fourth, square root of x to the fourth plus 2x squared dx. So in here, if we're going to do this one right away, as like this one, x raised to the fourth plus 2x squared raised to 1/2 dx. And then, so usually, we're going to let u, so to be x to the fourth plus 2x squared. Then so when we derive this will become 4x cubed plus 4x. So the problem with this is we don't have this one. We don't have the 4x cubed plus 4x at the given integrand. So therefore, we cannot just simply use the power rule here. And remember that we're just talking about 3 topics here. Okay? So it's just about antiderivatives using power rule, logarithmic, and exponential, or integral for exponential functions. So in such cases, so we cannot just use simply power rule here because we were not able to find the du on the integrand. So in cases like this, it just so happened that we substituted u right away. But looking closely at the given integrand, it would appear that for x to the fourth plus 2x squared is factorable. Okay, so that would make it, so if you factor this out, so this one will become, so what is common is x squared. So this would become x squared, then plus 2. X to the fourth plus 2x squared. And then we raise it to 1/2. So if we distribute the 1/2 there, so that is the same as x raised to 2 raised to 1/2, and then x squared plus 2 raised to 1/2 dx. And thus, so I'm going to start with x squared plus 2 raised to 1/2. And then x squared, this one, so x squared raised to 1/2, that is x. So 2 times 1/2 is 1. So therefore, that is just x dx. So this time around, I can now let u, so to be x squared plus 2. Then our du will become 2x dx. So this is x dx, this is 2x dx. So therefore, I'll have du over 2 is equals to x dx. And we transform. So x squared plus 2 is u raised to 1/2. And then x dx is the same as du all over 2. And thus this is 1/2 integral of u raised to 1/2 du. And then we get the integral. So 1/2. So u raised to 1/2 plus 1, that is 3 all over 2 all over 3 all over 2 plus c. And this is 1/2. The reciprocal of 3 over 2 is 2/3 times u raised to 1/2 plus c. So finally, so we have our answer, so to be 1/3. Okay. And u is x squared plus 2, then raised to, it should be 3 all over 2. 3 all over 2 plus c. So that is our final answer. Okay. So again, if we can factor out something on the given integrand, so try to do it. And lastly, so we have x minus 1 squared, so multiply it with x plus 3. Okay, so in this case, we have x minus 1 raised to 2. X minus 1 raised to 2, x minus 1 has a power of 2. But then, if we're going to transform this one into this format, as x minus 1 raised to 2, and then x plus 3 dx, then we're going to let u, so to be x minus 1, so since this is the one that has the power, so once we derive this is just dx. The problem is we were not able to get the x plus 3. Okay, so the x minus 1, its derivative, it's just dx. But what we want is to get the rest of the integrand. And we miss the x plus 3. So since we miss the x plus 3, so this is not the power rule. Okay, so right away, so using chain rule is not possible. Okay, so it's not possible. So therefore, the only way on how to do this one is to do it manually. Okay, so we need to expand. So that would become, so x minus 1 squared, so will be x squared, so minus 2 times x times negative 1 minus 2x, and negative 1 squared would be positive 1. And we have x plus 3 dx. Then so we distribute, so I'll start with the x. Okay, so I'm going to distribute x here, here, and here. So that one will become x cubed minus 2x squared plus x. X cubed minus 2x squared plus x. And then I'll do the positive 3. Okay, so I'll do the positive 3, distribute it again. So that one will become plus 3x squared minus 3 times 2 is 6x, and then plus 3 dx. So finally, so we combined like terms. So x cubed, then we have negative 2x squared and positive 3x squared, so that would be positive x squared. And then we have the x minus 6x is minus 5x. And lastly, so we just have plus 3. So multiply it with dx. And so we can use the power rule. So this one would become x to the 4th over 4 plus x cubed over 3. So minus 5 x squared all over 2. Then plus 3 times x plus c. To the 4th plus 4 plus x cubed over 3. Okay, so sometimes there's a trick here. The second option is not correct, so because this is missing 5 and then plus 3x. Okay, so in cases like this, be very careful. If it is a multiple choice type of question, then which is the most logical one, is we combine. Okay, so we get the LCD, and it would appear, so the LCD for 4, 3, and 2 will be 12. Okay, so that will be 12. So 12 divides 4 is 3. So 3x to the 4th. So 12 divides 3 is 4, x cubed. Then 12 divides 2 is 6. Minus times negative 5, so minus 30. Then 12 times 3 is 36. 30x squared. So 36x. Then plus c. So we move out 1 over 12. And that would make it, so 3x to the 4th plus 4x cubed minus 30x squared plus 36x plus c. So again, so once you had your quiz, this answer is already okay. It's already fine. As long as we have a positive exponent, that is already fine. But then just so happen that we're satisfying the format of the given. Okay, so if it's a multiple choice, so we follow the format on the choices. Okay, so if it is not, okay, so similar with the sample quiz. So this is sample quiz of my class last year. If that is the case, so this type of solution is already fine. But for multiple choice question, the format of the choices should be followed. Okay? So these are sample problems involving the use of power rule. Okay, so all of those are power rules. I'll be discussing as well. This is an exam. Okay, so this is the quiz. So quiz last year. So if you were able to solve this one on your own, so without looking at the solution, if you're able to solve everything here, then you are doing a right job. Okay. But then, if you are still not able to solve this one, I guess you need to practice more. Okay. So for you to pass our first quiz. Our first quiz would be similar to this, not exactly the same as this, but then roughly, okay, so it has something to do with this type of questions. Okay, so let's start with our first exam. Okay, so 6 points for 1 to 3. So I'm assuming that the first 3 questions are easy questions. And then quiz 4 to 7 are 8 points each. So that makes it 32 plus 18. Okay, so that makes it 50. Then I guess I multiply this one by 2. Anyways, so let's start with the integral of 3 plus x squared all over x times dx. So again, so in cases like this, so if there is an operation involved, so we need to perform the operation. Okay, so if there's an operation involved, so we need to perform the operation first. So in this case, so we have 3 plus x squared all over x, multiply it with dx. So what we need to do is, we can actually separate the two since it's a monomial at the denominator. So this is the same as 3 all over x, then plus x squared over x dx. And thus we have 3 over x plus x squared over x is just simply x dx. And thus, our answer here, so we have 3 over x, or that's just 3 dx over x. So the integral of that, so would be 3 ln x, okay? And then plus x squared all over 2 plus c. So this is fine, although sometimes, so we need to follow some properties in logarithm. So this is equal to ln of x. So we move up the 3, so it would become ln of x cubed plus x squared all over 2 plus c. So again, whichever of the two. So we may have an answer for 3 ln x plus x squared over 2 plus c, or ln x cubed plus x squared over 2 plus c. Okay, so that's how direct it is. Okay, so we just need to do the operation involved, and then right away, so we integrate. So again, in deciding, okay, so in deciding, so what method are we going to use? So we have to take a look at the degree of the numerator or the denominator. So in this case, so look at this. So the degree of the numerator here, it's 2. So the highest exponent of the numerator is 2. The highest exponent at the denominator is 1. Okay. So if the highest exponent, the numerator, is higher, okay, if it is higher or equal. So what we always do, we do division. So we do division. But if the denominator, so for example number 2, so we have a numerator which is 3, then the denominator is 4. A numerator which is 3 and denominator is 4. So that means it is lower. And then it is only lower by a factor of 1. Okay? So lower by 1. Lower by 1. So we do logarithm. Okay? So we do logarithm for such cases. So at least for the meantime, so this is what you need to remember. Okay? So if the numerator is higher, as long as it is higher or it is equal than the denominator, most of the time, so we divide. Okay? So we perform division. But if the power of the exponent or the power of the numerator is lower than the denominator by 1 only, in this case, this is 3 minus 4. Possible 3 and 4, a 2 and a 3, okay, a 5 and a 6, as long as it is 1. And most of the time, we do logarithm. Okay? So once we proceed with the other methods, those are the additional thing that we incorporate to what we know already. But for the meantime, this is what you should know. As long as the power is higher or equal than the denominator, then we do division. If the power of the numerator is less than the power of the denominator by 1, then we do the logarithm. So for example, for number 2, so we have 3x cubed all over x to the 4th plus 5 dx. So in this case, we have a denominator whose power is 4, and then the numerator's power is 3. So as I mentioned, so this would probably, okay, so be a logarithm. So in that case, if we're assuming that that is a logarithm, so we let u to be the denominator, so which is x to the 4th plus 5. And once we derive this, so that is 4x cubed dx. So which is the same as this. Okay? So x cubed dx. The only difference, okay, so the only difference is the 3. Okay, so the only difference is the 3 and the 4. Okay, so by the way, so what is the same is just this one. So x cubed dx, and then we have the x cubed dx. So what I want is I'm going to change the x cubed dx. So this one would become du all over 4 is equals to x cubed dx. So in this case, so this one would become, so 3 is not the same. So therefore, I'm still going to write 3 here. But then the x cubed over dx is the same as du over 4. So that means we have du over 4 here. Then multiply it with, we have the x to the 4th plus 5, which is at the denominator. So that is just simply u, or just 1 all over u. Okay, so we have 3, so we retain 3. And then the x cubed dx, so that is du over 4. And then the x to the 4th plus 5, so we retain it at the denominator. And now, so I can rewrite this one as the 3/4, so that is a constant, so I can move that out. So 3/4, and then I'll have du over u. And then recall that the integral of du over u is the natural logarithm of u plus c. And thus, this one is the same as 3/4 of ln u plus c. So which is 3/4, our u is x to the 4th plus 5 plus c. So that transform, or that would be our final answer. Okay, so for number 3, e raised to negative 1 over x all over x squared dx. Okay, so in here, so if you are seeing, if you can see, okay, so if you can see exponential function, So most probably that is one of the possible solution. So we're going to use the exponential function. Then we can see as well here a division. Okay, so 2x squared. So therefore, another possible solution would be power rule. Just so happen that we cannot use logarithm here because the exponent of e, or the Euler function, is raised to negative 1 all over x. And the power at the denominator is 2. So we don't know what's the degree. Okay, so at the numerator, since it involves a variable exponent, so therefore logarithm is out of way here. But then remember, in power rule, so the exponent involved should be constant. Okay, so power rule can only be used for exponents that is constant. So in this case, this is not constant. This is negative 1 all over x. So that is why the only formula that would be applicable here so far, so with the kinds of methods that we have, it's just simply EU du, okay? Or the integral of the Euler function. The integral of the Euler function EU du, it's just simply EU plus c. So we just need to make sure that once we derive our u, so we'll be able to get the rest of the function. So thus, in this case, so it's already given that u is the exponent of the Euler function e. So our u then would be negative 1 all over x. And to find this integral, so we can move out the x to the numerator. And thus our du then so will become negative. So x raised to negative 1 plus 1, so will become so we derive this one. Sorry, I'm integrating it. So we derive, so negative times x raised to negative 1. So negative 1 times negative, it would become positive. Okay, so positive x, and then negative 1 minus 1, what would be negative 2 dx. Or simply, so du is the same as dx over x squared. So what is the dx over x squared? This one. So dx over x squared is the same as du. So thus, so that is e raised to negative 1 x e. Negative 1 over x is the same as u, e raised to u. Then dx over x squared, which is this one, so that is du. So in short, that's we were able to transform it to an exponential function or the Euler function. So EU du then so will become just EU plus c. But then our u is negative 1 over x, or just simply e raised to negative 1 over x plus c. If we want to make it positive, so that is fine. So that would be 1 over e raised to 1 over x. So that is number 3. Number 4. So we have 4x minus 2 raised to x, then 3x plus 5 raised to x dx. So in this case, so there's an operation involved, so we do the operation first. So we use FOIL method. So we start with the first term. So first term, so we just combine. So that would become 4x and 3x. And then first, then the outer term. So 4x and 5x. So that would be plus 4x, 5x. And then plus inner term. So these are the inner term. So negative. So this one would become negative. So 2x times 3x. Then lastly, so we have the last terms. So that would become negative 2x, 5x. Then we multiplied it with dx. And then from here, so remember if we have let's say AB square, it's the same as a squared b squared. Okay. So we don't have the same base AB and then raise it to 2. So with the same exponent, so we can distribute the exponent. It's just simply the same as a squared times b squared. So following this property in algebra, so we can do it the other way around. If we are given a squared b squared, so we can write this one as ab raised to 2. So in this case, so we can write this one as simply 4 times 3 multiplied with x. That's the same thing. So 4 times 3 raise it to x. And then plus 4 times 5 raise it to x minus 2 times 3 raise it to x minus 5 or 2 times 5 raise it to x dx. And then so we can now multiply. So 4 times 3, that would be 12x. So 4 times 5 is 20x minus 2 times 3 is 6 raised to x minus 2 times 5, that is 10 raised to x, and then multiply it with dx. And remember the formula that the integral of an exponential function a raised to u du, that is the same as au all over ln a plus c. And that is what we will be doing here. So it's just a direct application. So we just have 12x all over ln 12 plus 20 raised to x over ln 20 minus 6 raised to x all over ln 6, and then minus 10 raised to x all over ln 10. And of course, d plus c. Okay, so that's just it. So for number 4. For number 5, so we have e2x, then multiplied it with ex plus 1 raised to 2. So again, so there's an exponential functions involved here, and then so there is e raised to x plus 1 and then raise it to 2. So it is possible that we can use the power rule, okay, because of the raised to 2. But then the problem here is if we let u to be ex plus 1, so its derivative would just be ex dx. So what we have here is e raised to 2x. It's not e raised to x. So therefore, we cannot use the power rule here. So if it is not possible to use the power rule, then most probably, so we do the exponential. But the problem in exponential, so once we let u to be 2x, okay, you have e raised to 2x. So most probably the u here would be the 2x. So once we derive du, that is 2 dx. It's totally far from here. So in those cases, we go back to the original. If there's an operation involved, so try to do the operation first. Okay. So in short, so we expand. So we expand this, so e raised to 2x. Binomial expansion for e raised to x plus 1, so that would become e raised to 2x plus 2 times e raised to x plus times 1, 2 e raised to x. Then 1 times 1 is 1 squared dx. or just 1. So we remove the squared. Then we distribute. So we distribute e2x to the 3 terms. So doing that, so that would become, so we just add the exponent. e2x times e2x, 2x plus 2x is 4x. Then plus 2, 2x times or plus x is 3x. Then plus e raised to 2x times 1 is e raised to 2x. So all of these, that would become dx. So we have multiple u's here. So u here will be 4x. Okay, so I'll write that one as u1. So u2 will be 3x. Then u3 will be 2x. So du1 then will be 4 dx. So du2 will be 3 dx. And du3 will be 3 dx. Okay, so in short, I can just simply, I'm not going to substitute anymore. So because definitely it will yield to this formula that the EU du is the same as EU plus C. So in short, the neutralizing factor here is just the inverse of 4, 1/4. Neutralizing factor here is 1/3. Neutralizing factor here is 1/2. So therefore, so we have, our answer then so will be 1/4 e raised to 4x plus, so we still have 2 there. So 2 times 1/3, so 2/3 e raised to 3x, and then plus 1/2 e raised to 2x plus c. Okay, for number 6, so we have x squared plus 7 then division x cubed plus 21x minus 5. So again, so there's a rational integrand given here. So for rational integrand, always one possible solution would be logarithm. Okay, that's the format for natural logarithm. It's a ratio. Okay, so it's a ratio between two functions. Okay, so just like what I mentioned a while ago, so try to take a look if it satisfies our criteria for natural logarithm. So the power at the numerator is 2. The degree of the denominator is 3. Okay, so the power of the numerator is lesser than the denominator by 1. So therefore, so possible is for the logarithm. So if we are assuming that the solution would be logarithm, so we let u to be the denominator, so which is x cubed plus 21x minus 5. So we derive this, so just simply, so x cubed, that will be 3x squared. So x cubed is 3x squared, and then plus 21. But then as you can see, 3x squared plus 21 is not the same as the numerator, which is x squared plus 7. But then du is factorable. Okay, so du is factorable. So we can factor out 3 there, so it will become x squared. So 21 divided 3 is 7, and that would be dx. So as you can see this time, so it's already the same. The x squared plus 7 dx is the same as this. So it just so happened that we have 3 there. Okay, so once we substitute that, so it will become du over 3 is the same as x squared plus 7 dx. So what happens? So this one becomes, so x squared plus 7 dx, that's the same as du over 3. Okay, so du over 3. And then we have the x cubed plus 21x minus 5, that is the same as u, which is at the denominator. Or just simply put, this is the same as 1/3 of the integral of du over u. Then recall, so these are the only formula that you have. So du over u is the same as ln u plus c. So thus we can now make this one as just simply 1/3 ln u plus c, or 1/3 ln, our u is x cubed plus 21x minus 5 plus c. So 1/3 ln x cubed plus 21x minus 5 plus c. Okay, so I don't have space anymore. I'll be adding another page. So I'll do the last one. So e raised to 4x, e raised to 2x minus 1. E raised to 4x, e raised to 2x minus 1 dx. Okay. So whenever exponential or the Euler function is involved, okay, so with so much terms, okay, so definitely we cannot just simply use the integral of exponential function or the integral of Euler functions. So it's because, okay, so the given integrand is so complex. So in cases like this, okay, so looking at the exponent, so most probably we have a 4 here. And then at the denominator we have a 2. Okay, so it's a difference of 2. So we have a numerator with a power most likely of 4. And then the denominator, it's most likely by 2. So in this case, so we can consider this one as an improper fraction. So we cannot use logarithm here. Okay, so we cannot use logarithm. But rather, so we're going to use, or we're going to divide. Okay, so because we were able to classify this one as an improper fraction. So how do we divide? So again, so we have a dividend of e raised to 4x, and then we have e raised to 2x minus 1. So we divide the first term. So e raised to 4x divides e with e raised to 2x is e raised to 2x. Then we multiply, that is e raised to 4x, then minus e raised to 2x. E raised to 2x times negative 1 is e raised to 2x. And then we change the sign, so this one will become negative, this one becomes positive. And thus we have e raised to 2x. So can we still multiply this one or divide this one? Yes, it's still e raised to 2x still the same as e raised to 2x. So that makes it e raised to 2x divided with e raised to 2x, that would become plus 1. Then so 1 times e raised to 2x is e raised to 2x. And 1 times negative 1 is negative 1. And we change the sign, so this one becomes negative, this one becomes positive. So thus, e raised to 2x minus e raised to 2x is 0, and then negative, or this one would become positive 1. So since this is 1 already, so therefore we can no longer divide. Okay, so we can no longer divide 1 with e raised to 2x. So in such case, so this one serves as our remainder. So in writing, so that would be the quotient, so e raised to 2x, and then plus 1, and then we add the remainder. So the remainder would become the numerator, and then the denominator is the divisor, which is e raised to 2x minus 1. dx. Okay. Okay, I'll try to solve this one in this way, and then I'll try to solve it on another way as well, because there's a simpler version of this. Anyway, so since I'm already here, I'll try to answer it in this way. So I can integrate e raised to 2x and 1. But then I'll have a dx. Okay. So this one, it can be easily integrated. So e raised to 2x plus 1, so dx. Then plus this one is the same as dx all over e raised to 2x minus 1. E raised to 2x minus 1. Since we have a rational integrand here, I can do if I'm going to let u to be e raised to 2x minus 1, so du will become 2 e raised to 2x dx. The problem is we don't have e raised to 2x at the numerator. So that is why what I'm going to do, I'm going to force, okay, so this one to have an exponential function at the numerator. So what will I do? So what I'm going to do is I'm going to multiply this one by the inverse of e raised to 2x. So this is the same as e raised to negative 2x divided with e raised to negative 2x. So doing so, okay, so I'll be forcing the integrand to have an exponential function at the numerator so I can integrate it so using natural logarithm. So this one will become then e raised to 2x plus 1 dx, and then plus so this is the same as e raised to negative 2x dx divided with e raised to 2x times e raised to negative 2x. So I'll distribute. So I'll multiply it here and then I'll multiply it there. So that will become e2x, e negative 2x. So that is just e raised to 0, which is just 1. Then minus e raised to negative 2x. So now I can now let the value of u. So the u here, so this is just an exponential function. It's just 2x. So du will be 2 dx. And then for this one, so this u1, u2, du2. So I'll have 1 minus e negative 2x. So this is 0. And then so I am deriving, so that is negative e raised to negative 2x. So derivative of negative 2x is negative 2 dx. So the u2 then so will become negative or positive. This is positive 2 e raised to negative 2x dx. So positive 2, right, e raised to negative 2x dx, which is the same as this. So we just have a 2. So du then, or my neutralizing factor then so will be 1/2. You can substitute or you can do it right away. So the answer here then so will be so we have a neutralizing factor of 1/2 here as well. So because of the 2 there. So thus our answer here so would be 1/2 e raised to 2x, and plus integral of 1, it's just simply x. And then I'll have plus the neutralizing factor of 1/2. So ln of 1 minus e raised to negative 2x. Then plus c. So that will be our answer then. Alternatively, I can have an answer. So I'm going to stop here. For example, in this case, Let's say I have e raised to 2x. So since if I'm going to stop here, it would appear that this would become my remainder. So therefore, I can write this one as just simply the integral of e raised to 2x, and then the remainder, so which is becomes our numerator, then the denominator is just 2x minus 1. Because once I let u, so to be e raised to 2x minus 1, so our du would just be simply e raised to 2x times 2 dx. So I'll just have a neutralizing factor of 1/2. So similar to this, so our du would be 2 dx. So therefore, our answer here so would just be a neutralizing factor of 1/2. So 1/2 e raised to 2x, and then plus 1/2 ln of e raised to 2x minus 1 plus c. Okay, so it's either we have this solution or we have this answer or we have this one. So let's try to check so whether those are the same or most probably these are equal. Okay, let's try to see if they are really equal. Not sure. Okay, so I'm just going to apply some properties. I want that one is positive, so this is negative, so I can make this as 1/2 e raised to 2x plus x plus 1/2 ln of 1 minus, then I'll transpose or I'll make that one positive. And then so 1/2 ln of, so take the LCD, so e raised to 2x, then this one will become e raised to 2x minus 1. Okay, so I'm having that one. Okay, so this is plus c, of course, plus c. Then I'm going to apply the properties of logarithm. So I'll have plus x and then plus 1/2. So we have divisions. Okay, so for ln, so I can separate the two as ln of e raised to 2x minus 1 and minus ln of e raised to 2x plus c. I'll have 1/2 e raised to 2x plus x plus 1/2. So ln e2x minus 1. So ln e raised to 2x is the same as minus 2x. Okay, so ln e will just cancelled out. Okay, or ln e, that's just the same as 2x plus c. Because we can do this one. 2x ln e raised to 1. Ln e raised to 1 is 1. So that makes it just 2x. And then finally, so 1/2 e raised to 2x plus x plus 1/2 ln of e raised to 2x minus 1. Then 1/2 times negative 2x is negative x. Then plus c. And then the x and the x would cancelled out. And it is the same as this one. Okay, so whichever among the two. And that's it for the answer of the problem set that I have provided you. This one is another set, so we have different given, okay, but the process is just the same, so I'll just be providing you the answer to that. So I leave that to you. Okay, so for your reference, if you have tried to solve that quiz. So the answer would be this one. And okay, so try to review. So this is the first quiz. This is the easiest. Okay, so among the quiz that will be provided to you. So far, this is the easiest topic that we have in integral calculus. So the methods will be more complex as we proceed with the topics on midterms. So topics on midterms are a bit longer. So that is why, so you need to have a high score. Okay, so for this first quiz. And that will be all. I hope that you can review, and I hope that you will be successful for our first quiz. And that will be all. Have a blessed Sunday and good day, everyone.